Next, I want to talk about a feat that some may have concluded must be a mathematical impossibility. That's right, we're bringing Calculator to iPad. Apple Pencil has changed the way you can take notes, draw, and even design with iPad. And now it's changing the way you do math with a feature we call Math Notes.
Welcome to Interface Studies. My name is Sadeh. There's a moment unique to iPadOS's Math Notes feature where your hand has just finished drawing the equal sign and the answer is already there. Not in a sidebar, not after you tap a button, just right there, in line with your own handwriting, as if the page just continued your own thoughts. That moment is what this video is about, because what's happening here is not just a clever feature in a maths app. It's a glimpse of a genuinely different idea about what a computer can be and how a person can think with one. MathNotes arrived with iPadOS 18 in September 2024. It was notable because it was the first time the iPad shipped with a calculator app at all. But the calculator here is almost a side note. MathNotes as a feature lives in two places: inside the Notes app and inside the new Calculator app. You write with an Apple Pencil or with your hand. Expressions, variables, equations, unit conversions, and even basic graphs. The system resolves them in real time. Write a equals 5, then write a times 12 somewhere else on the page, and the answer appears. Go back and change a to b, and every expression that references a updates immediately, automatically, and across the whole canvas. To understand why this is interesting, we have to appreciate what mathematical input has looked like in software for most of computing history. You type or you click through different apps and interfaces. Either way, the computer sets the terms. You adapt to the interface's syntax. You translate your thinking into a format the machine will accept. MathNotes inverts this. The pencil stroke, that is imprecise, variable, physically irregular, is the primary input. The system infers intent from it. This is what we call low-threshold entry. The cost of starting is identical to picking up a pen. No syntax to learn, no mode to enter, and no format to comply with. Now, handwriting recognition for maths is notoriously hard, harder than recognizing natural language text. Written language is essentially linear. Mathematical notation is two-dimensional. Fractions stack vertically. Exponents float upward. The symbol and its scope are inseparable. You can't parse it character by character. You have to understand the spatial relationships between marks. In most tools today, the question of recognition is largely solved. There are apps that have been doing this well for over a decade. MyScript Calculator is a good example. But what MathNotes and similar recent apps do differently is this. In most recognition-based tools, handwriting is a bridge. You write, the machine recognizes it. The marks get replaced by a clean typeset version, and the transaction is over. Your hand was a better keyboard. MathNotes asks a different question. What if the handwriting never needed to be replaced? What if recognition was not the end of the process, but the beginning of something continuous? In MathNotes, the answer appears alongside your marks, not instead of them. The handwriting stays. The layout stays. A variable you defined in one corner silently informs an equation on the other side of the page. The computation is not a separate event. It's a property of the page itself, alive as long as the marks are there. That shift from conversion to completion, from transaction to persistence, is the thing worth understanding. And it turns out that maths, with its formal precision and its spatial notation, is the clearest possible domain in which to see it. Now, the idea itself is not new. This is the RAN tablet. It was a flat surface covered in a printed circuit grid that tracked a stylus in real time. The stylus tip was pressure sensitive, deliberately calibrated to feel like writing with a real pen. Running on the tablet was Grail, or the graphical input language. It recognized a vocabulary of handwritten characters and symbols in real time. It understood context. Scribble over something to delete it. Write a label inside a flowchart box and it becomes part of that structure. It didn't just read marks. It read marks in relation to each other. Now, the purpose of the RAN tablet was different. Its marks were program specifications, instructions to be sent to a machine elsewhere. The surface where you wrote and the screen where results appeared were physically divided. Now, because of technology and the advancements, MathNotes collapses that gap. The surface where you write is the same surface where you see what your writing means. The page doesn't feel like a remote control for a computer elsewhere. It feels like the site where the thinking is happening. What changed between 1963 and 2024 isn't the intuition. The intuition was right all along. What changed, again because of technology, was the ability to fuse input, output, and computation into a single everyday object, and to make the results feel like part of your own marks, rather than a separate machine-owned layer. What's special about MathNotes is in the design. Let's talk about that a bit more. There's a distinction worth making carefully here, because it gets at what is genuinely different about this kind of interface. Most computational tools work on a request-response model. You leave your working surface, make a discrete request, receive a discrete result, and return. Even when it's fast, the structure is the same. There's a moment of handoff. Your activity and the computer's activity are separate. The transaction is complete and closed. MathNotes belongs to a different model entirely. You never leave the surface. The computation is a property of the marks themselves. The result is a consequence of your notations, not a reply to a question. Now, one might reasonably object. MathNotes still solves things for you. The answer just appears. You didn't work it out. Isn't that also a form of handoff? It is a fair challenge. And in one context, like a student practicing algebra, it is actually correct. If the computation is what you're supposed to be learning, having it done for you short-circuits the point. But that's not the context this kind of interface is designed for. The calculator has always solved equations. Nobody argues that it makes it substitutive, because computation, for most serious mathematical work, was never the point. The thinking happens before it. What actually matters is setting up the system, choosing the variables, expressing the relationships between them, deciding what to hold fixed and what to let vary, structuring the problem so its own logic becomes visible. That work, this intellectual architecture, stays entirely with you. The resolution is the last step, not the central one. The computation serves your inquiry. It does not conduct it. So the real question isn't does the computer do the computation, it's after it does, where does the intellectual structure live? Now, in a request-response model, the structure migrates. It lives in the exchange, in the output, in the thing returned to you. You are downstream of it. In a responsive surface, the structure stays in your marks. The equation is still there. The spatial arrangement is still yours. The answers are annotations on a system you built. Consequences of your notation, not substitutes for it. There is also a cognitive dimension that goes beyond who does what. In a request-response model, there is always a seam, a moment where you shift register from thinking to asking and back again. However small that gap is, it interrupts the chain. In math notes, the seam doesn't exist. You're always inside the reasoning. The surface is always already responding. Intelligence is ambient, not invoked. That's the actual difference. Not what gets computed, but whether you ever had to stop thinking to get there. That is what takes us to the broader point, and it goes well beyond the maths app. What Math Notes is demonstrating in a specific, constrained, remarkably clear-cut domain is a model of computing in which the medium itself becomes responsive. The page doesn't route your input to a computation somewhere else. The page is the computation. You write on it, and it thinks back. This is a very different model from how we usually conceive of computers. The dominant model for most computing history is the tool at a distance. You have a machine, you tell it things. It processes them, it tells you the results. There's a transaction. There's a layer of translation. There's a moment where your activity and the computer's activity are separate. The model Math Notes belongs to has many names: active paper, responsive media, or ambient computation. They all point to the same thing: intelligence as a property of the surface, not a service you query. This paradigm can go in many places. Music notation, chemistry apps, and even certain types of writing have a structure that could be made responsive. Imagine a writing environment where a name first mentioned in a document quietly populates an annotation beside the text as a property of the surface, present wherever the conditions are met, or where a sentence containing an empirical claim is silently assessed against a knowledge base, with a confidence indicator appearing in line, in the same register as the text itself. What all of these have in common is the structural requirement that made math notes hard for so long. The system must understand the formal content of informal marks. It must understand it well enough to extend it meaningfully. And it must do so in a way that leaves those marks intact and in place. The intelligence must be additive. The surface must remain yours. The interesting thing about these times is that the first condition is now more achievable than it has ever been, across a wider range of domains, thanks to advances in recognition and language models. The second condition, which is being able to maintain the primacy of the user's marks, is a design choice, not a technical constraint. It requires a certain level of conviction. Math Notes succeeded in maths because maths is a domain with a precisely defined formal structure, a spatial notation that is well understood, and a long history of people wanting to do it with their hands. But the underlying model is not specific to maths. It's a general architecture for what an interface between a thinking person and a computing system can be. Math Notes is AI-enabled in the strict sense. It uses on-device recognition models and a live computation engine. But the lessons it offers are structural. The first is about where intelligence sits in the loop. Most AI tools work like this: input, processing, output, request, then response. Even when it is fast, there's a psychological pause, the sense of having handed something over, of waiting to see what you get back. Math Notes puts intelligence inside the loop. Writing and receiving are simultaneous. There's no handoff. You are not querying a system. You are thinking with one, at least in the way you interact with that system. This takes us to the second point, which is about making AI invisible. No spinners, no thinking message, no confidence score. The answer appears in a typeface that sits comfortably beside your own handwriting. You don't see the model. You see the page change. That is a strong implicit claim about reliability as well. If the system was frequently wrong, it would need those caveats. Hiding the machinery is a design decision that forces the underlying technology to be quietly, consistently good. The third is spatial persistent state. The page is the memory. What you defined earlier informs what happens now. In math notes, the canvas is the context, and the intelligence is bound to a place, not just a sequence of prompts. The fourth is the absence of a mode switch. Most AI features live in a separate panel, a chat window, a magic wand button, a side drawer, whatever it is. You have to step out of your flow to invoke them. Math Notes requires nothing of that kind. The pencil is already in your hand. The page is already where you're looking. This is what Mark Weiser called calm technology. Systems that recede into the background of activity rather than demanding focused attention. The fifth is scope, and it's probably the most important lesson for anyone building in this space. Math Notes is narrow on purpose. It does one family of things, which is mathematical reasoning over handwritten notation, and it does them reliably. That narrowness is not a limitation. It is the condition that makes trust possible. You can learn what the system will and won't do, and you can build your own practice on top of that. In a moment when many AI products chase breadth, ask me anything, in any domain, do everything, MathNotes quietly demonstrates the opposite strategy. Choose a specific formal domain, design deeply for it, and let augmentation rather than substitution be the point. Now, scope doesn't mean make it about maths only or in the same way that MathNotes functions. It's about the structure and the philosophy of interaction. Finally, maths is a precise domain, a narrow one. That's exactly why it worked first. The conditions were clearer there than anywhere else. But the idea it demonstrates is not narrow. It is, in fact, one of the oldest unsettled questions in the design of computing. What would it mean for a surface to be genuinely responsive to the way a person thinks? Not as a tool you pick up and put down, but as a medium that participates. For most of computing history, that question lived in research labs, in speculative papers, in demos that impressed people and then disappeared. Math Notes is the first time it landed in the hands of anyone with an iPad and a pencil. Without a download, without a subscription, without a learning curve. The Maths app just happens to be where all of this became visible. The broader question, what else could be on this kind of interface and what would happen if it were, is still largely open.